Hippity hoppity! It's time for more math. I know you guys are so excited. There's got to be some bunny out there who is super excited to learn about volume. And we are going to talk about today the volume of a few different three-dimensional objects. One is the volume of a prism. Now, if you remember, a prism has two parallel congruent bases. And then the connecting sides are rectangles. The base could be a rectangle, in which case we call it a rectangular prism. It could be a triangle, in which case we call it a triangular prism. When we talk about volume, we're talking about the amount of space something occupies. So area is two-dimensional. Volume is three-dimensional. So the volume of a prism is the product of the area of the base and the height. So for instance, in a rectangular prism, this is the formula we use, B, capital B, because it's the area of the base times the height. Now, in each case, the area of the base is a different shape. So you're going to use your area formulas from the last section to find the area of the base and then multiply it by the height. So again, the base here is either a rectangle or a triangle for these kinds of prisms. By the way, I forgot to say that this is on page 475 in your books. So you guys can start taking your notes on page 475, and we're going to go all the way to page 479 for this video. So to find the volume of a rectangular prism, let's see if this is going to let me, let's go. Okay, there we go. If you want to look at this first example, a jewelry box is in the shape of a rectangular prism. What is the approximate volume of the jewelry box? Now, with rectangular prisms, we could actually, oops, I went too far. No. Oh, okay. So we can actually rewrite the base because the base is a rectangle and the area of a rectangle is length times width. So in a rectangular prism, you could also use this formula, length times width times height. Now, my length is 18.4. The width is this 14.8 if my ears aren't covering it. And then the height is 25.6, so the height from the ground up. So length, width, height, and all we're going to do is multiply all three of those numbers together. And we get large numbers because it's three things you're multiplying, 6,971.32. Now, since the unit used is centimeters, then this is 6,971 cubic centimeters is what the unit is going to be. Let's look at the volume of triangular prisms. So with the triangular prism, we're going to use the area of the base times the height. Now in this case, the base is this triangle here, so we have to find the area of this triangle, and then the height is 15.3, the length of that rectangular side. So area of a triangle is 1/2 base times height. So 1/2 times 6.5 times 8.25. And then again, the height is 15.3. So you can plug all these numbers in at once and multiply them all at once. We don't have to do these separately. 1/2, I'm going to make it 0.5 times the base times, ooh, this always does this to me, 8.25. This is the area of the triangle, and then times the height of the prism. So if you can make sense of my chicken scratch here. So if we multiply all of these together, let's just zoom, reset that zoom. If you multiply all of these together, then you get 410.23. And again, the unit here is, since this is inches, it would be, you can say cubic inches or inches cubed. So with area, we have square inches. With volume, we have cubic inches or cubic units, whatever it happens to be. Okay. Let's look at another example of this for triangular prisms. So for a triangular prism, this triangle right here is a right triangle. So the area of that triangle is 1/2 base times height. So if I multiply all those, that's the area of the base, And then we also multiply that by the area of the prism, which will be 5.2. So half the base times the height times 5.2. And I'll let you guys work that out on your calculator. But that unit then would be cubic millimeters for that one. The final one for this video that we're going to look at is volume of pyramids. We're just hopping right along. And a pyramid, you guys know, is a polyhedron, where one base is a polygon and 3 or more faces are triangles that meet at a common vertex. Now, the volume of a pyramid is 1/3 the volume of a prism with the same base and height. The height of the pyramid is the perpendicular distance from the vertex to the base of the pyramid. So in words, the volume of the pyramid is 1/3 the area of the base times the height. So it's the same formula, except it's not as much volume. Think about it. If I had a rectangular prism with a base and a height, and then I made that into a pyramid, it's basically shaving off 2 of the sides of that prism, so you're taking 2/3 of that away, and there's only 1/3 of it left. So here, for this pyramid, this one is a square pyramid. It has a square base. The area of the base times the height, and the height is always perpendicular to the base, just like with triangles and parallelograms and things like that. The height is always perpendicular to the base, and then it's going to be 1/3 of that. So if you look at this final example on page 479, the volume is 1/3 the area of the base times the height. So the base here is a rectangle, and we would multiply 3 1/5 times 1 1/2. Or this is 3.2, and this is 1.5, and this is 2.8 if you'd rather work with the decimals. So area of the base, 3.2 times 1.5 times the height of the rectangle, 2 4/5 or 2.8 times 1/3. And you can leave your answer as a decimal. It doesn't have to be a fraction. I'll let you guys work with decimals here. It's a little bit simpler to deal with. So the volume of the pyramid is about 4, a little over 4 or 4.5-ish cubic inches for that one. So really just 2 formulas: volumes of prisms, base times height; volumes of pyramids, 1/3 base times height. The challenge is that the base is sometimes a rectangle or sometimes a triangle, so that B has a few different formulas: length times width, or 1/2 base times height, depending on what the shape of that is. But that's all we have for volume for this lesson. I hope you guys have a good rest of your day, and don't forget to be good, because the Easter Bunny, I don't know, does the Easter Bunny come to your house? Let me know. Okay, bye.